Good evening, everybody. Today we'll start gravitation. In this chapter, you are going to learn about gravity, Newton's law of gravity, explain the term acceleration due to gravity, modify equations of motion of an object falling under gravity, distinguish between mass and weight, and find the relationship between them, define free fall motion, and explain weightlessness, illustrate the force of buoyancy experienced by a body immersed wholly or partially in a fluid, and state the principle of Archimedes and apply it to solve the problems. So let us study what do you mean by gravity. Gravitational force due to the earth is known as gravity. So it is very simple. The gravitational force due to earth is known as gravity, but it is a force of attraction which the earth will apply on all the objects in the nature is known as gravity. So you can see by the right side, a small boy is throwing a ball. The ball is easily reaching the earth. So it is by the force the boy has applied on the ball, and at the same time, the ball is being attracted by a certain force towards the earth. So this attractive force or this attraction which is applied by the earth on the object is known as gravity. So this gravity is applicable for all the objects on this earth. We call this as a gravitational force. So how did we come to know about it? It is by the Sir Isaac Newton, who was an English mathematician and a physicist, discovered gravity. When the Isaac Newton was sitting under a tree, that is apple tree, you can see by the side, when he was sitting, he was just resting under an apple tree, he saw an apple falling from a tree. So it came to his mind that why did the apple has fall towards the earth? So this small thinking led him to discover the gravity. So it is the Sir Isaac Newton who has discovered the gravity. We will study the law given by the Isaac Newton, that is Newton's law of gravitation. So what does it states? Every particle in the universe attract every other particle with a force. And this force is proportional to the product of their masses and inversely proportional to the square of the distance between them. So this is a law given by the Newton, Isaac Newton, about the gravitation. What did he say? That you can see, that is the right side you have a diagram. Consider the two black balls which I have shown you as M1 and M2. So say M1 is a mass 1 of the ball 1 and M2 is the mass 2 of the ball 2. So these two are been separated by a distance, say D. They are separated by a distance D. So Isaac Newton has given a law. It states that the attraction between these two balls, that is gravitational force of attraction between these two balls, is directly proportional. It directly depends on product of the masses, that is M1 into M2. That is product of their masses and inversely proportional to the square of the distance separating them. So this was a law given by the Isaac Newton. Now this proportionality has been removed by a constant, that is capital G. What is this capital G? The capital G is a gravitational constant. It has some constant value which doesn't change at any place on the earth, right? And its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square, which is called as a gravitational constant. It is always constant. It doesn't change at all. So this was a law which was given by the Newton, called as a Newton's law of gravitation. That is in SI unit, M, what do you mean by M? M is nothing but mass of the body, which is measured in kilograms, and force of attraction, F, is given in a term of unit, that is Newton, and R, which I have shown it as D, that is distance separating the two bodies, it is in meter, and accepted value, that is a constant value for G, is 6.67 into 10 to the power of 11 Newton meter square per kg square. So we studied about the Newton's law of gravitation. Let us study very important topic, that is acceleration due to gravity, right? So we all know, what do you mean by acceleration? What do you mean by acceleration? So in short, we can say that is change in velocity. Rate of change of velocity is called as acceleration. But when this acceleration is due to the gravity, it is called as acceleration due to gravity. The Earth's gravity accelerates the coin and the paper ball in downward direction. Since both the coin and paper ball reach the ground together, this acceleration is called as acceleration due to gravity. It means that whenever we throw a ball and whenever we throw a coin, both of them are under acceleration. So this acceleration is same for both the coin and as well as for the paper ball. We can say that acceleration due to gravity is independent of the masses. It doesn't depend upon the mass of the body. When they reach the earth, they both of them reach at the same time. It is because of acceleration due to gravity. So what is the SI unit of acceleration due to gravity? It is meter per second square. What is the SI unit? It is meter per second square. Now we will move on to the next important part, that is motion of an object under a gravity. We have equations of motion. Then what about the equations of motion of an object under a gravity? So here we have a first equation, that is S is equal to ut plus half gt square. So what is S? S is nothing but distance traveled. So distance traveled is equal to u is the initial velocity. U is the initial velocity. T is the time taken. What is T? Small t is the time taken plus half gt square. Here g is nothing but acceleration due to gravity. Half gt square. Secondly, we have v square is equal to u square plus 2gs. What is v square? V is nothing but it is a final velocity, which is equal to initial velocity plus 2 times the gravity and the distance traveled. That is where u and v are the initial and final velocities, and s is the distance covered in time t. So using these two equations, we can solve the problems which are based on motion of an object under the gravity. We will understand what do you mean by mass of a body. Mass of a body is a quantity of a matter contained in a body. It's very simple. That is, it is a quantity of the matter which is contained in a body, right? So this mass, we will not ask to any person what is the mass of your body, right? Because the mass is such a quantity which doesn't change at any place on the earth. That is the mass of a body. It is nothing but a quantity which is present in a matter, which is contained in a body, is called mass. So on the whole, we can say mass is constant on any place on the earth. Whereas weight, what do you mean by weight? The weight of an object is the force with which it is attracted towards the earth. So in short, we can say that mass and weight both are same, but mass will not vary from one place to the another place, whereas weight will vary from one place to the another place. When we go to the space, we feel weightlessness. But when we are on the earth, we feel the weight of our body. So we cannot say our body has some mass. It is a weight of our body. So we can say it is a weight of an object is a force with which is attracted towards the earth. So we can say F is equal to W. By the definition of the weight, we can say F is equal to W. What is F? Force. That is, force is equal to weight. Then what is the formula for force? Force is equal to mass into acceleration. That is, mass into acceleration due to gravity, m into g. So from the equation 1 and 2, I can say that weight is equal to mass into acceleration due to gravity. So that's what the definition says. It is the force with which it is attracted towards the earth. So that is nothing but weight. So weight is mass into gravity, whereas mass is only the mass of the body. So this is a basic difference between the mass and the weight. Very interesting topic, weightlessness. What do you mean by weightlessness? Weightlessness condition experienced while in a free fall in which the effect of gravity is cancelled by inertia, right? So whenever a body is been falling towards the earth, we call it as a free fall, right? That body will experience a condition which is nothing but weightlessness. Why does that body will experience the weightlessness is because the force of the gravity which is applied by the earth will be cancelled by the inertia of the body. What do you mean by inertia? Inertia is nothing but mass of the body. So the mass of the body and the gravity of the earth get to cancel to each other. As a result, the body will feel weightlessness. So that condition is called as a weightlessness. So the best example during a free fall, the only force which is acting on the body is a force of gravity. It is the only one force which is acting on our body, and it will be cancelled by the inertia of our body. Even the astronauts will also experience the weightlessness. We will understand what do you mean by buoyancy. The upward force exerted by the water on the wooden block is known as force of buoyancy or buoyant force. So this force is also known as upthrust. Let me explain. You can see in a diagram, there is a brown wooden block which has been floating on the surface of a water. So when you place a wooden block on the surface of a water, there are two chances. First chance, the block may sink into the water or it may float on the water. But in this condition, the block is floating on the surface of the water. So what is the reason for the floating? It is because whenever we place a wooden block, there are two forces acting in the opposite direction. First force is a force of a gravity. Force of a gravity which is been applied on the top surface of the wooden block. And the another force which is exactly acting in the opposite direction is a buoyant force, which is called buoyancy. What is this buoyant force? You know already what is gravity. We will understand what is buoyant force. This force is nothing but the force which is applied by the water in an upward direction. The force which is applied by the water in an upward direction to the objects which are placed on its surface. So this force is called buoyancy, or we can also call it as a buoyant force, or it is also called as a upthrust. So what do you mean by upthrust? So the force which is applying in an upward direction, and thrust is nothing but force into perpendicular distance. Always the upthrust force is in perpendicular direction. When the upthrust force is greater than the gravitational force, which has been applying above the wooden block, the object will float. The object will float. If the upthrust force is less than the gravity, then the object will sink. And the phenomena is called as a buoyancy. So very important principle, that is Archimedes principle. Archimedes has given his principle which states that when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. So Archimedes has given his principle. So what does it says that whenever a body is immersed fully or partially, either it may be immersed completely or it may be partially it is immersed. So it will experience, that is the immersed body will experience a force which is in upward direction, which is equal to the weight of the fluid displaced by it. So you can see in a diagram here on the right side, there is a block which has been immersed completely. In the first diagram, it is not yet immersed. In the second one, it is immersed completely. So in the first case, it is showing its weight as 7 kg. You can see here. In the first one, you can see the block. It is showing as 7 kg on the upside, first diagram, right? It is showing as 7 kg because it is not completely immersed yet. When we go to the next one, B diagram, it is showing the weight as 4 kg. So same block, we can see the same block, there is no difference. Why there is difference of 3 kg here? It is because it has immersed completely, right? And it has displaced its weight, which is equal to the fluid which has been displaced. Whenever we immerse this wooden block, it has displaced a fluid. So how much amount of fluid it has displaced? Exactly 3 kg. Hence, it will experience the less 3 kg in its weight. So this is what the principle given by the Archimedes. What he says that if you immerse a body, it may be a fully or partially, if you immerse a body, it will displace the fluid. And that fluid will be exactly similar to the weight of the body or the upthrust force experienced by the body. The best example we will come across in our daily life. Whenever you immerse a mug in a bucket, completely filled bucket, the water will spill out. If you jump into a swimming pool, the water will spill out. So how much water is spilled out? The amount of upward force we experience, so much water will be spilled out. So this is what the principle given by the Archimedes. We have some of the applications of Archimedes principle. So let us study about that. So first principle application, it is used in designing ships and submarines. So this principle was being used in designing the biggest ships and submarines. And this principle is also used in the hydrometers. What do you mean by hydrometers? These are being used to determine the density of liquids, which is again based on the Archimedes principle. It is also used, the principle is also applied in the manufacture of the lactometers. Lactometers also work on the principle of Archimedes, which are used for determining the purity of the milk. So lactometers are the meters which are used to determine the purity of the milk, or you can say the density of the milk. So these are some of the applications of Archimedes principle. Let us move for the very important part, that is question and answers. We will discuss some of the question answers based on this. Why do two students sitting close to each other not feel force of gravitational attraction between them? So when the two students are sitting close to each other, they do not feel any gravitational force of attraction. So what is the reason? Any answers? Okay. Gravitational force is extremely weak, right? So when we compare to the weight of the students, gravitational force is extremely weak. Therefore, small masses do not attract each other due to this force. Distance between two bodies is increased by a factor of 4. How much will be the change in the force of gravitation? So you have to use here the Newton's law of gravitation formula. What they are telling, distance between the two bodies is increased by 4. How much will be the change in the force of gravitation? So we have a formula F, that is G is equal to, or F is equal to capital G into M1 M2 by D square. So what happens? Yes, as the force of gravitation is inversely proportional to the square of the distance between the two bodies, so the force will decrease by the factor of 1 by 16. So here force will be decreased by 1 by 16. That is 4 4s are 16. 4 square. Why is G known as universal gravitational constant? Why it is known as universal gravitational constant? Okay. The value G is same everywhere on the earth or in the universe. Therefore, G is known as a gravitational constant. As I told you, its value is same everywhere on the earth. So it is a universal gravitational constant. What do you mean by acceleration due to gravity? So we have studied what do you mean by acceleration due to gravity? Okay, any answers? What do you mean by acceleration due to gravity? Yes, the acceleration produced due to force of attraction by the earth is known as acceleration due to gravity. Why do a heavier and a lighter object, when dropped from a same height, fall at the same rate? Right? Though they are different in their masses, why do they fall at the same rate? Any answers? Okay, because the acceleration due to gravity is same for both heavy and light objects. As I told you, acceleration due to gravity is independent of the masses of the body. So it is same for heavy and light objects. State SI unit of acceleration due to gravity. So what is the SI unit? Okay. SI unit for acceleration due to gravity is meter per second square. So it is same as acceleration, that is meter per second square. Write equations of motion of an object moving under gravity. So you have equations of motion. So what are the equations of motion? So we have V is equal to U plus GT, S is equal to UT plus half GT square, V square is equal to U square plus 2G square. Sorry, 2GS. State two factors on which weight of an object depends. So two factors on which the weight of the body depends on. We have studied what is weight. Yes, weight of an object depends upon mass of the body. Secondly, acceleration due to gravity. That is, we have W is equal to M into G. So it depends on mass of the body and acceleration due to gravity. What will be the weight of an apple while it is falling from a tree? So whenever it is falling from a tree, it is a free falling object. They're asking what is the weight of an apple? It is 0. because it will experience weightlessness. What do you mean by buoyant force? We have studied, right? What do you mean by buoyant force? When an object is immersed in a fluid, it experiences an upward force, which is known as buoyant force. Okay. Does the buoyant force act on a body when it is kept in vacuum? Yes, when it is kept in vacuum, does the buoyant force act on a body? Any answers? Okay. No, it doesn't, because in vacuum there is no application of the buoyant force. What do you mean by vacuum? Without air. State two applications of Archimedes principle. Any two applications of Archimedes principle. Okay, applications of Archimedes principle. First one, in designing ships and submarines. Secondly, in the hydrometers or lactometers. So hydrometers used to find out the density of a fluids, lactometers to find the density of the milk. State Newton's law of gravitation. Every particle in universe attracts every other particle with a force. This force is proportional to product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the two particles. So this is nothing but called as a Newton's law of gravitation. So you can see diagrammatically two balls, that is a mass m1, m2, which are separated by the distance, that is r. So we can say F is equal to m1 m2 divided by r square, which is nothing but Newton's law of gravitation. Who defined the law of gravitation? Okay, you have options here. Is it Newton, Archimedes, Galileo, or Faraday? Okay, any answers? Very simple. Who defined the law of gravitation? Okay, so it is a Newton. Sir Isaac Newton brought out his monograph titled Philosophy Naturalist Principia Mathematical in 1687. In this work, Newton described universal gravitation and three laws of motion. So in this book, he has written the gravitational law and the three laws of motion. The atmospheric air is held to the earth. How it is held? Is it because of gravity, winds, clouds, or rotation of the earth? It is by the gravity. The atmosphere is the layer of gases around the earth. It is held in places by Earth's gravity. It is made up of mainly nitrogen, that is 78.1%. It has plentiful oxygen, that is 20.9%, and small amounts of argon, about 0.9%, carbon dioxide, that is 0.035%, water vapor, and other gases. So this is composition of our atmospheric air. So it is held by the gravity. It is easier to carry 2 buckets of water in one hand each than to carry only one hand, because so we can carry the 2 buckets in 2 hands easily than to carry in one hand. Why? Because weight of buckets are balanced, or center of gravity falls within the body, or center of gravity and center of equilibrium fall within the feet, or is it because of resultant weight of the buckets is zero? So any answers? Okay. It is because of center of gravity and center of equilibrium fall within the feet. It is easier to carry 2 buckets of water in one hand each than to carry only one in one hand, because the center of gravity and center of equilibrium fall within the feet. The weight is spaced out more evenly on both the sides of the body than it would be if you had to carry in a single bucket. So weight is equally distributed when you carry the buckets in each hand, both. Small bubbles are perfectly spherical because of. So bubbles are perfectly spherical. What is the reason? Is it because of gravity? Is it because of pressure, viscosity, or surface tension? It is because of surface tension. Liquid drops always assume spherical in shape because drops always tends to acquire minimum surface area due to surface tension, and for a given volume, the surface area of the sphere is minimum. Raindrops fall from great height. Which among the following statements is true regarding it? They fall with that ultimate velocity which are different for different droplets. They fall with the same ultimate velocity. Their velocity increases and they fall with a different velocity on the earth. Their velocity increases and they fall with the same velocity on the earth. Any answers? So whenever a rain falls, so which of these statement is true? They fall with that ultimate velocity which are different for different droplets. So option 1 is correct. Any mass is attracted to the earth by the pull of gravity. So gravity accelerates all objects towards the ground at a specific rate. Speed of a raindrop increases with a drop size. Its mass increases with the cube of a drop size, and air resistance force increases more slowly with the square of the raindrop size. So it depends on the air resistance and the size of the drop. So they fall with the ultimate velocity which are different for different droplets. A parachute descends slowly, whereas a stone dropped from the same height falls rapidly. Because so whenever a parachute will come towards the earth, it descends very slowly, whereas a stone drops very rapidly. Because option 1, stone is heavier than parachute. Special mechanisms are present in parachute. Third one, a parachute has large surface area and air resistance is more. Lastly, none of the above. Any answers? Okay. That is, option 3 is correct. A parachute has a large surface area and air resistance is more. Yes, obviously. Gravity is pulling the man down while friction with the air slows him down. With the parachute out, it adds more friction, slowing him down because air resistance works against the very large surface area of the parachute. So it is the air resistance which acts on the large surface of the parachute. So it comes down very slowly. The shape of a raindrop is spherical due to, is it because of viscosity, surface tension, elasticity, or gravitation? Okay, it is because of option B, that is surface tension. A person can jump higher on the moon surface than on the earth because, what is the reason, right? The moon surface is rough. Second one, the moon has no atmosphere. Thirdly, the acceleration due to gravity in moon is smaller than that of the earth. Fourth one, the moon is cooler than earth. So any answers? So why can we jump higher on the moon than on the earth? Okay. The acceleration due to gravity in moon is smaller than that on the earth. So option C is correct. Gravity is less on the moon than on the earth. Ball pens work on the principle of. So we all write with the ball pens, right? So on what principle it works? Is it works on the principle of viscosity or Boyle's law? Is it because of gravitational force? Or lastly, capillarity and surface tension? So any answers? On what principle does the ball pen works? Okay, it is last option, capillarity and the surface tension. So here the lead will act like a capillary tube and the ink, when it on the surface of a paper, will follow the surface tension principle. So it works on the principle of capillarity and surface tension. In the earth, the weight of a body is maximum at the North Pole, is it at South Pole, equator, or the surface? The weight of the body is maximum at, it is at the surface. As we go from equator to North Pole, the value of G, that is gravity, the acceleration due to gravity, what happens to it? Does it remains the same or does it decreases? Thirdly, increases or none of the above? So as we go from equator to the North Pole, the acceleration due to gravity remains same, decreases, increases or none of the above? It increases. When compared to the equator of the earth, the radius is less at the poles. Yes, the radius is less at the poles since the earth is considerably flat at the poles. Right? The earth is not exactly spherical. It is considerably flat at the poles. The acceleration due to the gravity at the equator is about 9.78 meter per second square, whereas the acceleration due to the gravity at the poles is 9.83 meter per second square. So we discussed some of the question answers, right? So let us see what all we learned in this chapter, right? So in this chapter, we learned about gravity, Newton's law of gravitation, and we explained the term acceleration due to gravity. We also modify the equations of motion of an object falling under gravity, distinguish between mass and weight, and we also find the relationship between them, that is W is equal to m into g. We found the relationship between them. We define free fall motion and also explain what do you mean by weightlessness, and illustrate the force of buoyancy experienced by the body which is immersed wholly or partially in a fluid. We also state the principle of Archimedes and apply it to solve the problems. So these are some of the topics we learned in this chapter. There are some more questions. You can visit to the edurapid.com site. You can solve some of the questions and practice for your exams. If you have any questions, you can ask. Any doubts, any queries, you can clear, you can ask.